Have you ever looked up at the night sky, at that vast velvet canvas dusted with countless stars, and felt a profound sense of wonder? Each of those pinpricks of light is a sun, many of them just like our own. Around them, we now know, orbit worlds beyond our wildest imaginings. It is in these quiet moments of contemplation that a question, perhaps the most ancient and persistent of them all, rises within us. Where did we come from? It is a question that has driven our science, our philosophy, and our art for millennia. We often tell ourselves a simple story. Life began here, in the primordial oceans of a young Earth, a chance combination of chemicals, a spark of energy, and from that miraculous moment, a chain of evolution unfolded over billions of years, leading to the rich tapestry of life we see today, including ourselves. But what if that is only part of the story? What if the very beginning, the initial spark of life, did not happen here at all? What if humanity, and indeed all life on Earth, has its origins far out there amongst the stars? This isn't a thought born of science fiction, but a genuine scientific hypothesis that invites us to reconsider our place in the cosmos. So what exactly is the seeded species theory? At its heart, it is a very simple yet revolutionary idea. It proposes that life did not necessarily originate on Earth. Instead, the fundamental building blocks of life, or even simple, hardy microorganisms, were transported to our planet from somewhere else in the universe. Imagine cosmic dust, asteroids, or comets acting as interstellar vessels, carrying the precious cargo of life across the immense distances between stars. These celestial travelers, after a journey that could last millions of years, would then impact a young, habitable planet like Earth, delivering their payload and seeding the world with the potential for life to begin. The first is that the raw ingredients for life, complex organic molecules like amino acids, are abundant throughout the universe. In this version, space is like a cosmic kitchen, constantly mixing the ingredients for life's recipe. The more dramatic version of the theory is that actual living organisms made the journey. This is the core of the idea known as panspermia. It suggests that extremely resilient microbes could survive the harsh conditions of space, effectively hibernating for eons. Upon arriving at a new home like the early Earth, with its warm oceans and abundant resources, these microbial pioneers could awaken and begin to thrive, multiply and evolve, eventually giving rise to all the complexity we see today. The idea that life is a cosmic traveler is not as modern as it might sound. The concept of panspermia, which is Greek for seeds everywhere, has roots that stretch back to ancient Greece. The philosopher Anaxagoras, in the 5th century BC, proposed that the seeds of life were present throughout the cosmos and could be carried to Earth. It was a remarkable piece of intuition, a philosophical musing that predated our understanding of microbes, space, and the nature of the stars by more than 2,000 years. In the 19th and early 20th centuries, this ancient idea was revived and given a more scientific footing by brilliant minds like Lord Kelvin and Svante Arrhenius, a Nobel Prize-winning chemist. Arrhenius in particular championed the theory of radiopanspermia. He hypothesized that microscopic spores could be propelled through space by the gentle but persistent pressure of starlight itself, drifting from one solar system to another like celestial dandelion seeds caught in the wind. Later in the 20th century, the theory was further refined by astronomers Fred Hoyle and Chandra Wickramasinghe. They proposed that comets were the primary vehicles for life's distribution. They argued that the warm, watery, and chemically rich interiors of comets could serve as ideal incubators for primitive life. Today, the idea of panspermia is taken seriously by many scientists. The discovery of extremophiles, organisms on Earth that can survive in unbelievably harsh conditions, from the boiling water of deep-sea vents to the frozen deserts of Antarctica, lends it credibility. If life can survive in such extreme environments here, it is plausible that some forms could survive the rigors of space. When we ask where life came from, science currently offers two principal narratives. The most widely accepted is abiogenesis, the theory that life arose from non-living matter right here on Earth. It paints a picture of a young planet, a chaotic but energy-rich environment. In this primordial soup of chemicals, powered by lightning strikes, volcanic heat, or ultraviolet radiation from the sun, simple organic molecules gradually self-assembled into more complex structures. The seeded species theory, or panspermia, offers a compelling alternative. It does not necessarily contradict the fundamental principles of abiogenesis. It simply proposes a different venue for the event. Perhaps another world, at another time, had a more stable environment, or a richer chemical mixture that allowed life to get its start more easily. From that single point of origin, life then spread outwards, carried on the backs of asteroids and comets. The comparison between these two theories highlights a key scientific challenge: the sheer improbability of life's beginning. The transition from a random collection of chemicals to a self-replicating metabolizing organism is a monumental leap. Panspermia suggests that if this event is exceptionally rare, it only needed to happen once in the entire galaxy. The universe is vast and ancient, containing billions of planets that have existed for billions of years. Ultimately, these two theories are not necessarily mutually exclusive in a broader cosmic sense. Perhaps life has started independently on billions of planets across the universe. Or perhaps both are true. The universe is under no obligation to be simple. The debate between a local origin and a cosmic seeding is a wonderful driver of scientific inquiry, pushing us to explore our world and the cosmos for answers. The idea that humanity or life came from the stars is not confined to scientific laboratories. It resonates through our oldest stories and mythologies. Many ancient cultures across the globe have creation myths that speak of gods or ancestors descending from the heavens to bring life and knowledge to Earth. The Sumerian texts describe the Anunnaki, powerful beings who came from the sky. The Dogon people of Mali have complex astronomical knowledge of the star Sirius that they claim was given to them by visitors from that system. This theme of cosmic ancestry is not just found in ancient tales. It's also hinted at within our own biology. The very atoms that make up our bodies, the carbon in our cells, the calcium in our bones, the iron in our blood, were forged in the heart of a dying star billions of years ago. When that star exploded in a brilliant supernova, it scattered these heavy elements across the galaxy, providing the raw material for new stars, new planets, and eventually for us. Furthermore, some scientists have looked for more direct biological clues. They have searched for what they call a message in the bottle within our DNA. The idea is that if an advanced civilization had intentionally seeded life on Earth, a concept known as directed panspermia, they might have encoded a signature or a message into the genetic code of the organisms they sent. Could there be a pattern, a mathematical sequence, or a piece of information hidden within the vast library of our genome, waiting for a species intelligent enough to read it? The sudden appearance of complex life forms during the Cambrian explosion, after billions of years of simple, single-celled existence, is a puzzle that still intrigues scientists. The seeded species theory offers an alternative perspective. Perhaps this explosion was triggered by the arrival of a new, more advanced set of genetic instructions from a cosmic source, acting as a catalyst for evolution. The seeded species theory forces us to ask a fundamental question about our planet. Is the Earth a unique, isolated oasis of life in an otherwise sterile universe? Or is it just one garden among many in a vast cosmic forest teeming with life? The theory of seeded species turns this perspective on its head. If the seeds of life are cosmic travelers, then it's highly improbable that Earth was their only destination. Our galaxy, the Milky Way, contains hundreds of billions of stars. We now know that planets are the rule, not the exception, and a significant fraction of them may be rocky worlds orbiting in the habitable zone, where conditions could be right for liquid water. If life can be transported between stars, then it stands to reason that countless other worlds have also been seeded. This changes our entire search for extraterrestrial life. Instead of listening for complex radio signals from advanced civilizations, we might begin by looking for the telltale biosignatures of simpler life on nearby worlds, like Mars or the moons of Jupiter and Saturn. Finding even a single microbe on Mars that shares a common genetic ancestor with life on Earth would be a revolutionary discovery. Thinking of Earth as one garden in a larger forest also carries a profound environmental message. If the life here is not just our life but a local expression of a universal phenomenon, it becomes even more precious. We would be the custodians of one branch of a galactic family tree. the biodiversity of our world would not just be a planetary treasure, but a cosmic one. The responsibility to protect it, to understand it, and to ensure its survival would take on a new and deeper meaning. We would be preserving a piece of a much grander story, a story that connects all life, everywhere. Imagine for a moment that we found definitive proof. A probe on Mars drills into the ice and finds frozen bacteria with DNA. A telescope analyzing the atmosphere of a distant exoplanet finds the unmistakable chemical signature of photosynthesis. The confirmation that we are not alone, that life was seeded here from the cosmos, would fundamentally reshape our understanding of ourselves. Our entire sense of identity, as a species and as individuals, would undergo a profound transformation. The story we tell ourselves about who we are and where we belong would change forever. The discovery that we are just one of many seeded species would be the ultimate Copernican revolution, moving us not just from the center of the solar system, but from the center of biological significance. We would have to accept that we are not a unique miracle, but a variation on a cosmic theme. Our science and philosophy would be thrown into a golden age of inquiry. Biology would become galactic biology. We would ask questions we'd never dreamed of before. How does life evolve on a planet with two suns, or one with higher gravity? Are there other forms of genetic code? Finding that we are part of a larger biological family would give us context. We could begin to understand what aspects of our own biology and society are universal products of evolution and which are unique quirks of our planetary history. This newfound context could also have a powerful unifying effect on humanity. The realization that every person on Earth shares a distant extraterrestrial origin could render our terrestrial conflicts and divisions petty and insignificant. Faced with the knowledge of a universe full of life, the concept of us could expand to include all of humanity, and the concept of them would become our unknown cosmic relatives. It could inspire a new era of global cooperation as we collectively turn our attention outwards to the stars, united in a shared quest to find and understand our place in this vast living cosmos. If we are indeed a seeded species, then somewhere out there we may have relatives. The search for extraterrestrial life, or SETI, is no longer just a search for aliens, it becomes a search for our own extended family, for the other branches of the tree that grew from the same ancient seed. This search is already underway, using the incredible tools of modern astronomy. The James Webb Space Telescope, for example, is not just peering back to the dawn of time, it is sniffing the atmospheres of distant exoplanets, looking for the chemical fingerprints of life. The search is also happening much closer to home. Robotic rovers are diligently exploring the surface of Mars, drilling into ancient lake beds and river deltas where microbial life might have once thrived, or could still be dormant today. Missions are being planned to fly through the plumes of water erupting from Saturn's moon Enceladus, and to land a probe on Jupiter's icy moon Europa, whose subsurface ocean is considered one of the most promising places to find life in our solar system. This search requires more than just powerful telescopes and clever robots. It requires a new way of thinking. We must be open to the possibility that life might not look like us, or even be based on the same chemistry. We listen for radio signals, but we also look for the subtle dimming of starlight that indicates an orbiting planet, for the infrared glow of industrial heat, or for atmospheric gases that are out of chemical equilibrium, suggesting they are being maintained by a biological process. Ultimately, the search for our cosmic kin is a reflection of our own innate curiosity. It is the grandest adventure our species has ever embarked upon. Whether we find single-celled organisms on Mars or detect the faint hum of a technological civilization in a distant star system, any discovery would be a turning point in human history. It would confirm that we are part of something larger than ourselves. The act of searching itself is a noble one. It's an expression of hope, a testament to our desire to know, and a fulfillment of our destiny as a conscious species capable of questioning its own origins. So, where does this leave us on this small blue world on this particular day, looking up at the sky? The seeded species theory, whether it turns out to be true or not, gives us a gift. It gives us a sense of profound connection to the universe. It reminds us that the boundary between Earth and space is not a barrier, but a permeable membrane. The cosmos is not something separate from us. We are a part of it, and it is a part of us. The iron in our blood and the calcium in our bones were born in the heart of a star. We are stardust, animated by the mystery of life. This perspective invites us to live with a sense of wonder. It encourages us to look at the world around us, from the smallest microbe to the largest whale, and see it not as an isolated accident, but as a local chapter in an epic cosmic story. It suggests that the drive to explore, to reach for the stars, is not just a whim, but a deep-seated instinct, a call to trace our own origins back to their source. Our curiosity is the universe's way of becoming aware of itself. Every question we ask, every telescope we build, is a step on that journey of cosmic self-discovery. This does not diminish the beauty of Earth. It enhances it. If our world is one of many gardens, it is our garden. It is our responsibility to tend to it, to protect its incredible diversity, and to cherish the unique evolutionary path that life has taken here. We are the custodians of this precious outpost of life. We are the consciousness of this world, and for now, we are its voice in the cosmic conversation. Our ability to understand this, to even contemplate these ideas, is perhaps the most wonderful thing of all. In the end, the question, "Are we alone?" may be less important than the way we live with the question. It pushes us to be better, to be more curious, more cooperative, and more humble. It inspires us to look beyond our immediate horizons and to see ourselves as part of a grand and unfolding narrative. Whether our family tree is rooted solely in the soil of Earth, or its seeds have drifted across the interstellar winds, we are here now. We are a part of the universe that can look back at itself in awe, and that surely is a magnificent thing to be.